Hi, my name is Vicky Ramsey and I've been studying physics since 2006. This is episode 5 of my ENA video series. In episode 1, I talked about general relativity in relation to the calibration of atomic clocks, and how, according to general relativity, a clock should require less energy in order to tick faster. When it is my observation that in the real world, an atomic clock actually requires more energy in order to tick faster. Where, if I am correct in my observation, general relativity would have to be amended to state that clocks tick faster higher up within a gravity potential, and clocks tick faster in the greater gravitational field. In episode 2, I talked about how this amendment to the theory of general relativity would not require any changes to the general relativity equations, and how the addition of only 6 operations of modification in the form of axioms provides an alternative to the current interpretation of the general relativity equations. In episode 3, I talked about how interpreting the general relativity equations under the remit of these 6 axioms results that the universe cannot currently be expanding and would instead be contracting. I also talked about how, via these modifications, the redshift distance correlation can be reinterpreted. In episode 4, I talked about how this reinterpretation of the redshift distance correlation can provide cause and effect mechanics for the 5 sigma Hubble tension, and I hinted as to the notion that, under the remit of this reinterpretation, the Hubble tension could be regarded as empirical evidence with which to support a contracting universe hypothesis. I want to talk here about this contracting universe hypothesis and my proposal for a cyclic contracting bounce cosmology. So, to give a bit of background, in episode 3, I outlined the existence of cosmological models other than the Big Bang theory, and the fact that most of these models have been found to be implausible for one reason or another. However, in the case of bounce cosmologies, while some types have been ruled out, other bounce cosmologies are respectably investigated. For instance, to illustrate just a few, theorists at Perimeter Institute have been investigating the idea of the universe having undergone a contraction period that occurred previously to the expansion scenario of the currently held Big Bang theory. And Paul Steinhardt and Anna Aegis have been working on a cyclic bounce cosmology inherent with a slow contraction process as opposed to a collapse. But point of fact, these investigations are regarding bounce cosmologies that place our universe as being currently in the expansion phase. And although there are theorists that have suggested that the universe may not be expanding, due to the fact that they have not been able to present what the field may construe as being conclusive evidence to support their hypothesis, they have not been taken very seriously. What I wish to discuss here is my proposal for a cyclic bounce cosmology that places our universe as being currently in the contraction phase. In episode 1, I outlined existing evidence that, if I am correct in my analysis, proves that the current interpretation of the general relativity mathematics is flawed, and that the universe cannot be expanding and must instead be contracting, albeit very slowly. In episode 4, I talked about how our local galaxy group is part of a galactic supercluster named Laniakea and is caught up in a phenomenon known as a galactic flow, where all of the galaxy clusters within the superclusters that comprise Laniakea are moving at a speed known as a peculiar velocity towards a location in space dubbed as the Great Attractor. I pointed to the fact that the peculiar velocity of the galactic flow is a separate phenomenon from the Hubble constant of the Hubble flow. I also gave full details of my reinterpretation of the redshift distance correlation outlining how the redshift observations can be reinterpreted as being only partially due to Doppler shift. However, to recap in brief, different methods of measuring the Hubble constant result in different speeds. Whereas, according to the Big Bang theory, the Hubble constant should be the same speed for all light sources. By taking the CMB, this being the cosmic microwave background, measurement as a baseline, any other method of measuring the Hubble constant, for this instance, let's say Cepheid variables at 74.03 kilometers per second, can then subtract the CMB speed of 67.4 kilometers per second from their result. And the remainder, 6.63 kilometers per second in the case of the Cepheid variables, is then the reinterpreted measure of the Doppler shift related speed. And these new greatly reduced measures of Doppler shift speeds, which will all be slightly different depending on the type of light source, are now not describing the rate at which galaxy clusters are expanding away from each other. They are now a description of the speed at which these different light sources are converging upon each other within their specific galaxy cluster groups. And, as is already observed via existing data such as Cepheid variables as compared to red giants, light sources that are located in more dynamical areas of space will have higher Doppler shift speeds, where more dynamical locations in space can be thought of as having the presence of more energy. This is then in keeping with my proposed addition of the axiom plus energy equals shorter seconds, where galaxies converging upon each other, i.e. moving into regions of space inherent with seconds getting shorter, will then move at progressively greater speeds. And conversely, when moving into regions of space inherent with seconds getting longer, a body of mass will move at progressively lesser speeds. These being some of the observable effects of a hidden time dimension that I have proposed as being inherent to space itself, where this effect is now giving us a partial description of cause and effect mechanics for how gravity does what gravity does. And as a mathematical function, what I have just described here is basically really nothing more than a simple case of a constant speed and a constant distance being held relative via the speed-distance-time formula to a variable time function. Okay, so the rest of the redshift observation is then attributed solely to this proposed hidden time dimension, and is caused by the rate of time in space in the voids between galaxy clusters becoming slower. This being because the distances between galaxy clusters are increased due to the galaxies of these clusters becoming ever closer to each other. And as the energy becomes greater within the region of space that the galaxies of a cluster group are converging into, as a result of this convergence, the energy of the space within the voids between the galaxy clusters themselves becomes lesser. Where the mechanics of this hidden time dimension effect requires one to envisage that, rather than the light being stretched by the length of the distance that the light is travelling through in space being increased, that the light is being stretched by an increase in the lengths of the seconds that are inherent across the distance of space that the light is travelling through. It is in this manner that the redshift distance correlation can be reinterpreted, where the Hubble tension, that is an anomalous problem for the Big Bang theory, in my model actually becomes a retrodiction in support of my proposal for a cyclic contracting bounce cosmology. So, going back to the peculiar velocity of the galactic flow that is moving the galactic supercluster known as Laniakea towards a phenomenon that has been dubbed as the Great Attractor, in an expanding universe, while it is accepted that galaxies within galaxy clusters are gravitationally bound, it is thought that the galaxy clusters themselves are expanding away from each other due to the space in between them increasing, where the observed structures of superclusters and galactic superclusters will then evolve to become increasingly further dispersed as the expansion of the universe progresses. However, cosmologists are perplexed regarding the data concerning the galactic flow towards this great attractor phenomenon. The peculiar velocity of this galactic flow is in the region of 600 kilometers per second, where in consideration that, as per the Big Bang theory, the currently accepted so-called Hubble constant speed of the Hubble flow, dependent on the method of measuring, is only in the region of between 67.4 kilometers per second and 74.03 kilometers per second. 600 kilometers per second, by comparison, is really very fast indeed. And of course, the universe is comprised of zillions of galaxy clusters that, in assuming our neck of the woods is not an anomalous feature, are going to be the constituents of supercluster structures, and superclusters will, in turn, be the constituent parts of galactic supercluster structures, where, by logical deduction, it stands to reason that each of these galactic supercluster structures has their own version of a galactic flow, and are moving with peculiar velocities towards their own versions of great attractor phenomena. It is even further perplexing to cosmologists that, in addition to the fact of the Laniakea superstructure being caught up in a galactic flow, there is located in the opposite direction of the galactic flow a very large tract of space that is almost completely devoid of galaxies, where again it would be logical to suppose that large tracts of open space, supervoids if you like, will be predominant in a universe that is comprised of galactic superstructures that are moving towards great attractors. In the Big Bang theory, it is an inherent feature that there will be voids between the gravitationally bound galaxy clusters and that these voids will be expanding. But the observational fact of the supervoid that Laniakea is flowing away from, and the notion that such supervoids may be predominant throughout, is somewhat anomalous to the Big Bang theory expectation. I dare say that the James Webb Telescope will be in a better position to inform us as to if there is a universal presence of galactic superstructures that are being subject to peculiar velocities and galactic flows, and if so, whether these galactic flows are resulting supervoids throughout the entire universe. However, with respect to the observations regarding Laniakea, the data is already well documented. Okay, so my modification of the interpretation of the general relativity mathematics and the resulting cyclic contracting bounce cosmology actually predicts that there will be galactic superstructures moving at peculiar velocities within galactic flows towards great attractors throughout the universe, and that superstructures and supervoids will have evolved and be further evolving due to the universe contracting at a rate with a very slow acceleration. In the Big Bang theory, it is hypothesized that the universe will evolve from its present state as per an accelerated expansion, where galaxy clusters, under the influence of gravity, will eventually collapse into massive black holes, which will then become further isolated from each other as the voids of space between them increases with the expansion of the universe. These massive black holes will eventually radiate away via Hawking radiation, where the universe will carry on expanding forever and eventually reach a state of thermodynamic equilibrium, or heat death as it's otherwise known. Okay, so that's the Big Bang theory. My cyclic contracting bounce cosmology hypothesizes that the universe will evolve from its present state as per an accelerated contraction. that galactic superstructures under the influence of galactic flows will collapse into great attractors, where great attractors are supermassive black holes and galactic flows are the influence of gravity. And as the universe further contracts, these supermassive black holes will merge with one another, to the point that all of the mass of the entire universe will eventually merge into a singular gargantuan black hole, where at the precise moment that the very last merging occurs in order to cause this gargantuan black hole, due to the sudden lack of any other gravitational force acting upon this singular gargantuan black hole, it will then transform into a white hole that immediately spews out all of the energy stroke matter of our current universe in the form of radiation stroke particles to seed the beginning of a new universe. This new universe being the next cycle of the ongoing process of a cyclic contracting bounce cosmology. The colossal amount of energy stroke matter ejected by the white hole will be distributed almost homogeneously across a space, the volume of this space being caused by and proportional to the magnitude of the energy stroke particles, where the slight anomalies in the homogeneity will cause variations in the rates of time for both the hidden time dimension of space and the time dimension for mass, that will then ensure that an anisotropic contraction process will ensue, to evolve energy stroke matter into fields of gas that will form into stars, and the conglomeration of matter will result in tracts of open space, where the stars will eventually result carbon structures that will form into clumps that will converge to form planets. And the stars will form into galaxies that will eventually form into galaxy clusters that will form into superclusters, etc., etc. Okay, so as a point of comparison, there are actually quite a few problems with the Big Bang Theory. A few too many to address in this video. However, apart from the surface brightness problem, which is suggestive in itself that the universe is not expanding, the main problems with the Big Bang Theory are that there has not been enough time for the cosmic microwave background to evolve to its observed homogeneity, nor enough time for the evolution of the observed large-scale structures of mass, where the fixes the theory requires to survive these problems are complicated, lack naturalness, and actually create more problems that then require further fixes. Whereas my cyclic contracting bounce cosmology has none of these problems. As a mathematical function held relative to the current timing of a clock here on Earth, it hypothesizes that since the advent of the last white hole ejection process, it has taken in the region of around 220 billion years for the universe to evolve from an almost homogeneous sea of radiation stroke particles into the complexity of structures comprising the universe as we currently observe it. Okay, so please note that by adding the axiom clocks tick faster higher up within the gravity potential and clocks tick faster in the greater gravitational field, this statement being the consequence that the calibration process when engineering an atomic clock shows that a clock requires more energy in order to tick faster. Contrary to the current interpretation of Einstein's general relativity, where the physics breaks down when applied to black holes, my modification of general relativity results that time in a black hole ticks fairly fast, where the bigger a black hole is, the faster the rate of its time. And black holes are not singularities, but are highly compressed bodies of matter and energy stripped down to constituent part subatomic particles. And this highly compressed energy and matter is incredibly hot, where, due to the intensity of the gravitational field, the heat does not escape easily from beyond the event horizon. And, to say so, this proposition is entirely consistent with the mathematics of the temperature of a black hole being inversely proportional to its mass. where my modification of general relativity then does not break down and can actually describe the physics of black holes while using the existing mathematics, albeit via an alternative interpretation. Okay, so now to white holes. The concept of a white hole already exists within the current interpretation of the general relativity mathematics, and is quite simply a mathematical time reversal of a black hole. In my model of a cyclic contracting bounce cosmology, as per black holes, the physics of a white hole are also an alternative interpretation of existing mathematics. However, I really will have to get into the nitty-gritty of dark energy, entropy, and the arrow of time as a means of further explanation. And these are topics that I will be discussing in episode 6. Meanwhile, I have left links to all of the aspects that I have discussed today in the video notes. Thanks for watching.